This video is about expanding and combining, or sometimes it's called condensing, logarithmic expressions. For our notes, we're simply going to say we need to recall all the laws of logarithms. We're not going to add to that list of laws, but we're certainly going to be applying them. So if needed, go back and review, take a quick look at them. There are three main laws and a couple other properties that go with them that we'll be using. Our first example reads, use the laws of logarithms to expand the expression. So we want to pay close attention to what we're being asked to do here. To expand would mean we're going to end up taking what looks like a nice bundled up log expression and then spreading it out as much as possible using all of our laws. Our first example reads, log of y cubed over the square root of 2x. Let's observe that in the biggest picture, this log really does have a quotient as its input. Everything after the log is in a large fraction, where it has a numerator at y cubed and a denominator square root of 2x. So if we go back and recall what our quotient log law said, we can split that up in the following way. We turn it into a difference of logs, where the first term in this difference is the log with the same base, so now it's just a log base 10 with the base not even written, of the numerator. So we have log of y cubed first, the numerator. Then we subtract log with the same base, but this time of the denominator, so square root of 2x. So that's our first step, just kind of applying the quotient law of logarithms here. But there's more we can do, as you can probably tell here. We have a power with the y, the input of that first log term. That power could be thrown down in front using the power rule or law, so that that can turn into 3 times the log of y. All right, if we keep going, you'll notice the second term, the log term, was the log of the square root of 2x. It seems like that's kind of locked together, but we can unlock it simply by rewriting the square root as a power. So we're going to write this as 2x to the 1/2 power instead of the square root of 2x, because then we can use the power property and more, the power law and more. Let's go ahead now and rewrite again. So we'll have 3 times the log of y minus this power of 1/2 will be thrown right down in front and become 1/2 times the log of 2x, just like that. But notice now the log of 2x has 2x as the input, but that's a product, which means we can go further. So let's rewrite yet again. We'll have 3 times the log of y. That's our initial first term there. Just going to keep copying down here for the rest. And then minus 1/2. Now, when we split this last log term up, we're going to have to do so carefully, putting it in a set of parentheses. So we're going to split it to be log of 2 plus log of x. So notice the parentheses are there because this negative sign really would have to be distributed to both of those terms. It's really easy to forget that if those parentheses are not there. Let's now rewrite what we have yet again. So we have 3 log of y out front. Then we have minus 1/2 log of 2 minus 1/2 log of x. So don't forget that minus came with the 1/2 when it got distributed, and it's easy to forget that. So we'll double check the signs, everything's looking good. Now you might go through and wonder if we can reduce anything. The first and last terms do have some variables, which means those aren't really going any further. But you'll notice this middle term says 1/2 log of 2. It almost seems like, can we reduce that with the 1/2 and the 2? Well, be really careful to understand what this is really saying. Remember, this log, as we've seen from the start of this problem, was not given a base, which means it's really log base 10. So this is really 1/2 log base 10 of 2, but log base 10 of 2 is really not something that we can reduce easily. There's no power of 10 that would equal 2. So since that cannot be reduced, that's fine. That just means we'll leave it where we have it. and make sure this is our answer. Let's try another example where we want to use the laws of logarithms to expand an expression. Again, understand that we're expanding. It's good to know what the goal is here. The given expression is log of, now this is going to be kind of crazy here, but it's log of the square root of x times the square root of y times the square root of z. But those are all nested square roots, so that the square root of z is tucked underneath the previous root, which is all tucked underneath the first root. I think the best way to address a complex expression like this is to color code things. So I'm going to add those colors in and refer to them as needed. The outermost root, the first one we see, I'm just going to put in a blue color. The next root, I'm going to put in a green color. And the most nested last root, I'm going to put in an orange color. Let's see if we can navigate our way through expanding this complicated log expression, and I think the colors will probably help us out. We're going to begin by rewriting this thing, but converting the blue outermost root to a 1/2 power, which we know it represents. So we'll write this as log, and then I'm going to use some parentheses instead of the root, wherein we'll have the x still that we had originally. Then we'll have the green root, which contained a y. Then we'll have the orange root, which contained z. I'll close up the blue parentheses and recognize that the whole point of what we just did is that now those blue parentheses on the outside should have a 1/2 power because we just converted that blue root into a 1/2 power. Well, as soon as we do that, we can utilize the power law, which would mean we can take this power 1/2, which is the power of the entire log input at this point, and we can throw that power all the way down in front, so that now we have 1/2 times log of x times the square root of y. Now I'm using the green color for this, which includes the square root of z inside of it. Now I'll close up the outermost blue parentheses. So we've taken care of one of the roots by taking its power of 1/2 down in front. Notice we have a couple other roots that remain. So as this starts to unpack though, we're going to have to keep in mind that inside the input of the log, which is all the things left, which would be x times the square root of y times the square root of z. That all still applies to any logarithm laws we have. You'll notice inside there, if you consider the x times the green root, the root of y times square root of z, then that's really another product, which means our next step is to split that. You see, we can't really start to unpack the next root until that root is covering the entire input of the log, but it's not at this point. We have this x times the green root that remains. So let's go ahead and split this another step. We'll recopy the 1/2 in front, keep our log, but this time we're going to make this splitting up using the product rule. So we'll put our x as the first factor input, and then we'll say plus, and then we'll have to rewrite another log, and then after we're going to use the green root of y, and then the orange root of z still within it. Now, if you look very carefully at what's written, there's actually something wrong with it. Can you spot it? If you look really carefully, okay, you'll recall that we just took a logarithm and split it up in two different directions. We took a product and split it into a sum, but in the previous step, the 1/2 was being multiplied by that entire log, which means now we should have parentheses around everything after the 1/2 because we would have to distribute the 1/2 to both of those terms inside. All right, let's take this another step, and now we'll rewrite with the 1/2 in front. Keeping the notation we've had at the previous step, we'll have now in parentheses log of x plus log, but then instead of writing this green root, I'm now going to convert that into a parenthesis. So we'll have parentheses containing y square root of z, and that will be to the 1/2 power. So now this green set of parentheses corresponds to the green root we had at the previous step. Let's continue now with another step where we'll copy everything we already have. So 1/2, parentheses opening up with a log of x inside, plus. Now we're going to use the power rule again to throw the 1/2 that was from the green parentheses and root down in front of that log, so that we have now 1/2 log of y square root of z. And so as you can see, we're kind of unpacking or unfolding all of these powers which came from all of the roots. Let's continue yet another step. Just for convenience, I'm going to drop some of the colors here. We have 1/2 open parentheses log of x plus 1/2 log. Now, the y times square root of z that we had in the previous step as the input, that's a product, which means we're going to split that up into a sum of logs. So we'll have log of y plus log of square root of z. But then, as we've seen already previously, we should use parentheses to contain what just got split up there, since the 1/2 that was in front would need then to be distributed to both of those terms. So let's go ahead and rewrite another step. We have 1/2 times log of x plus, now if we distribute the 1/2 into these last two terms, we'll have 1/2 log of y plus 1/2 log of z, but you'll notice it's not z, it's square root of z, which means there's yet another 1/2 power to deal with. So it's really z to the 1/2. All right, so then let's continue, and we'll do one more step of bringing that last power of 1/2 down in front, and then finally clean it all up. So we have 1/2 way out in front still, we'll deal with that in a second, times log of x plus 1/2 log of y plus, now this 1/2 from the z power is going to come down in front and make this a 1/4 log of z. Okay, finally, all the exponents are used up. The only thing left to do would be to distribute this 1/2 that's way out in front to all the terms, which would give us a final result of 1/2 log of x plus 1/4 log of y plus 1/8 log of z. Let's try another example, but this time we're going to use the laws of logarithms to combine, or sometimes it's called condense, the expression. Notice this is a different purpose than the previous problems, which were expanding. So it's kind of like we're going in reverse order now, and that would make sense as you look at our first example. It reads 3 ln of 2 plus 2 ln of x minus 1/2 ln of x plus 4. Of course, ln means natural log, which is log base e, but we can keep using the abbreviation ln for that. You'll observe that this problem seems to be starting where the expand problems were finishing. In other words, it's kind of all spread out, but we want to bundle it back up together into a single logarithmic expression. As you might also recall, if you go back and review the expand examples, it was often the case that the last thing we did, or the last law we used, was the power law, where we brought the powers down in front. It might make sense then for when we're condensing or combining in reverse order to go in reverse order with those and do the power rule or power law in reverse first. So in the first term, which was 3 ln 2, using the power law, which would seem like backwards by now, but it really doesn't have a direction, we could say that's really ln of 2 cubed. The 3 that was in front of the ln becomes the power of the input of that natural log expression. We'll keep moving on. Next, we'll write this as plus ln of x squared, doing the exact same thing. We're bringing these powers up in front. And lastly, we'll say minus ln, and then the 1/2 power, if we brought that 1/2 up to the top, it would turn into a square root. So it's really natural log of the square root of x plus 4. All right, so after doing just the power rule at that step, we'll go ahead and proceed, but now go, again, order of operations, so left to right with addition and subtraction. our left pair of logs that are being added would turn into a product. So we'll call this the natural log of the product of 2 cubed, which by the way is 8, times x squared. That's the product of the two arguments from the previous step being put together in a condensing fashion. This is not a new law, it's just using one of the laws in the opposite direction. We're going to copy down everything else we had, so minus natural log of square root of x plus 4. And then next, notice that with subtraction, we can turn that into division. But also look very carefully when you use the quotient logarithm law, you only end up with a single logarithm in the result. It's common to think you have a logarithm in the numerator and in the denominator, but we only put ln once. The numerator and denominator are occupied by the inputs from the previous step, the first one being the numerator, so 8x squared will go up top, and then the square root of x plus 4 down below. And then you could put parentheses around this to be super clear about what is the input of the log, but some textbooks may not put that level of parentheses on these. But either way, here's our condensed form.